Okay, so this is the first problem of today's educational round. And in this problem, we're given that we have monocarp and he has found a treasure map. So the map represents the treasure location as an OX axis. So basically, he's currently at 0 and the treasure it is at X and the chest is at Y. So in one move, he can go in left or right direction. He can either like all these three steps take 0 seconds. So basically picking up, dropping, picking up the chest or dropping the chest or picking up the key or opening the chest. These all take 0 seconds. So other than this, we are given that we can for at most k seconds, monocarp can carry the chest and this is possible for only k seconds. So we have to find the minimum time when monocarp will be able to open the chest. So this is a very simple problem. If we are at 0, let's suppose this is X, this is Y. So at X, we have the chest and at Y, we have the key, right? There are only two possible scenarios that Y and X. So if this is the case, the answer is simply this X, Y, because on the way to chest, monocarp can simply pick up this key. Otherwise, what will happen? We can move this K steps forward. Let's say this is the point after K. So drop the chest here, pick up the key and come back. It's also possible that K, like maybe after K, you can like probably drop the chest somewhere here. So don't drop it there, drop it here only. So this is the maximum point where you'll carry the chest up to. So the logic is clear to everyone, right? There are only these two scenarios. Okay, so let me show you the implementation. So this is the implementation. In case y is less than x, simply output x. Otherwise, x is less than y, move your xk units forward. Then take your x to be minimum of x or y because you don't have to go after y. Finally, your answer is going to be up till y plus if in case x is still less than y, y minus x because after picking up the key, you'll have to come back to the chest. Is this thing clear? Okay, so let's go to the next problem. So this is the next problem. In this problem, we are given that we have a sequence of integers a of size 2n, and we have to split these 2n integers into n pairs such that these integers, like these pair of integers, represent the point coordinates of points on a plane. So let's suppose we went through each of these points. So we have to minimize the length of that path. So let me explain it here. So let's suppose these were those two end points. There are 6 points. So maybe we'll have this as the 3 points if we combine these two, these two, these two. So this is the path length, right? So we have to choose these points in such a way such that we can minimize this length. So if we look at this problem closely, let's suppose these are those two endpoints. If we sort these points and we say that these first 4 points are going to be x coordinates and these last 4 points are going to be y coordinates. So let's say you have to go like if what is this distance? You are moving in y direction this much, and if you optimally do this, you'll only move in your x, like in this scenario you are moving in your y direction, x direction this much and then this much. Like this is what you're moving in your y direction, plus y minus y, first 28, and this is your in your x direction. So if you do this optimally, what will happen? You will only move in positive y direction and somewhat in positive x direction, like maybe something like this, right? So what we can do, we'll say that these 4 points will be x coordinates and these 4 will be y. So this, like, what is the maximum that you'll go in x direction is this minus this. So this minus this, and in y direction, this minus this. So basically pair these 2 points, then these two, then these two, and then these two. So if you do like this, in x direction, you will be going this much distance, the difference between these two, and in y direction, you'll be going the difference between these two. So the total that you'll be moving is the sum of these, this and this. Is it clear? This is the total distance that you'll move. Is it clear? Yes, no? Or is there any doubt? Okay, it's clear. What about others? Like, why only some people are like responding in the chat? Okay. Okay, I'll show you the implementation. So this is the implementation. First, take the two n integers in input, then sort them. So this is the difference between n and first integer. This is the difference between 2n integer and n plus 1th integer. After sorting, finally print your pairs. So I hope no one is having doubt in this. So going to the next problem. So in this problem, we are given that we have a ticket. Like a ticket is a non-empty string of digits from 1 to 9, and a lucky ticket is such a ticket such that it has an even length. The sum of digits in the first half is equal to the sum of digits in the second half. Now we are given n tickets, and we have to count the number of pairs such that pair ij such that si plus sj is a lucky ticket. Now I can be equals to j also. Like I can be like ij can be same. So how to do this problem? See, what is a lucky ticket? So a lucky ticket should have length as even and sum of, let's say if length is n, so sum of 0 to n by 2 should be sum of digits of 0 to n by 2 should be same as sum of n by 2 to n, right? So we have to count all the pairs ij such that the concatenation, like the string that we get, the ticket that we get as the concatenation of these two is a lucky ticket. So what we can do, see, for each string, we'll try to find the possible j's. Like what are possible, like for the current string, let's say the current string is I. For every string I, we will try to find all string j's such that we can fit them here. We can place them here, and this thing will be a lucky string. And we'll also try to find for this thing what are all the strings that can be placed here such that this thing is a lucky string. So for each string I, we just have to find the count of these, right? And finally our answer will be nothing but for all string i's, the sum of these counts. So now the thing is how to achieve this. See, the length of each string is up till 5 only. So what is the maximum length that the sum of like the concatenation of two strings can be? It can be 10 only, right? Yes, no. Now let's say we have our current string something and it has length n. So we'll be adding either a string of length, like let's suppose the string this n is even. So we'll be either we will have the concatenated lucky string, which is having this s, either the length of that will be n plus 2, n plus 4, all the way up till 10, right? Yes, no. Okay. And if n was odd, then this will be n plus 1, n plus 3, because this will be even, right? This is the length of the lucky, like the string that I will get after concatenation. So let's pick this thing. If the length is n plus 2, so this is the n length of this string, right? So first, let's consider that this is n plus 2. This is my string s, and a 2 length string will come here. So can I not find what is the total of this part, this half? It will be nothing but total minus the value of this thing. Total is the total of digits of string s minus, let's call this as b. So I'll subtract this thing, total minus b, and what should be the sum of this string? It should be, can anyone tell me, for this complete to be a lucky string or lucky ticket, what should be the sum of this? Anyone? It should be, if this is b, this should be, why it should be total minus 2b? Add b into it. See, this is the complete string. This length is 2. This is 2. So these two will, like, this is the half part. Like this part, this thing will combine. Like this thing is second half. This thing is first half. First half sum is total minus b. So second half sum should be also total minus b. But what is the sum that I'm getting right now? Let's call the sum of this as x. So x plus b should be equals to total minus b. So x should be, x is the sum of this part, like the second string, like the string of size 2. It should be total minus 2b. Is it clear now? Like the sum should be total minus b. Is it clear? So you just have to see for this length, for this string, you just have to find, like add the number of strings which are of length 2 and which have sum, like digit sum as total minus 2b. Now I'll come to this, how to do this, but let's come to first another thing, which is when the string s is here and I have a 2 length string in front. Like 2 can be anywhere, right? In back also, in front also. Again, let's call this as the sum of this part as a. The sum of this part will be total minus a. The pass, what should be the sum of this string? The size 2. What should be the sum of this thing? Assume it x plus a should be total minus a. So x is total minus 2a. So again, if this has to be a lucky ticket, I'm not breaking, like this s is like the complete length is n plus 2, right? So half characters will be in first half, second half, like the rest of the characters will be in second half. So if the second half is this thing, like some of the characters are getting here, right? Coming here, which will be in first half from the string s. So the sum of those is a. Is it clear? Okay. So then again, for current string s, you'll have to find the count of all the strings which are of length 2 and which have total minus 2a as the sum. So this we will do for each string. And the thing is, we should, like string s is this, we should only see, you can do this in any manner, but the point is, if you do this to avoid recalculation or multiple calculations, what we can do, we can assume that the length of the current length of complete string will be less than 2 times n. Why? Because if length becomes more than 2 times n, let's say this is your complete length, your string s is smaller than 2 times n. So this will be your mid. So what will be your a? Like I'm saying that a part is that which belongs to a string s, but will be coming with in another half, right? If your length is, try to understand this. If your length is more and your string s is only this much, what will be your a or what will be your b? Nothing, right? There are things that you can come to overcome this, but it will unnecessarily complicate. So instead of what can be a simple hack that we can sort our strings according to increasing size? Like sort your strings in increasing order of their sizes and then do the same thing. For the current string, let's say the string is S, size is N, do the same thing. Like if the current size is N, then if N is even, then check for all of these. Like this should be the ticket length, this should be the ticket length, this should be the ticket length up till 10, or when till up till length is less than 2n. But the thing is, once you do this, if this is the ticket length, then you have to do this thing. Find the sum of this part, then count this thing. How many strings are there which have length 2 and which have this much sum? Or count the strings which have this much length and this much sum. Is it clear? And add it to your answer. You will do this for each string, you will do it at max 5 times, because n plus, like if you keep doing this at max 10 times, like it is actually 5 times only because we are doing plus 2 plus 2. Is it clear? Like why we are doing this if length is less than 2n? Because there is no point after that. Like once you have sorted, like you will get zeros only for that. But the thing is, see, this is your complete length, and I said that some part of a will go to some, like another half. But here what is happening, some part of another string is coming to this current half. This is your string S. So you haven't actually like calculated those strings, like the strings which have bigger size. This thing will eventually contribute. Like if you are thinking like this pair, we are leaving this pair for string S. No, we are not leaving it. It will actually get calculated when you will be covering, like when you will be doing for this string. Then you will get this pair. But right now, if you start for, like if you are worried about this pair, how can you get it? Because this is string S. There is some part which is coming in this half, but you haven't gone through this string yet. So you don't know actually what is this. Do you get my point? So that's why for string S, only cover those length tickets whose sizes length is less than or equals to 2n. Is it clear now? If you're covering tickets of size more than 2n, then by default your string S is smaller and some other string is bigger. And you actually haven't looked for these kinds of string. And if you do the other way around, if you're going in reverse order, then probably you would have looked at these strings but not smaller. So the one way to do this is first sort your and look only for strings which are less than or equals to S. Like the size of those strings is less than or equals to S. Okay, this much is clear. Now the only thing is how to get these counts, right? Yes, no. So this is very simple. See, length of strings is only up till 5. So let's make a map. You can make a vector of maps or an array of maps of size 5. And for each, you don't actually require a map also. You can do this using a 2D array also, or a 2D vector. But let's say you make a map of size 5 and map of, let's say 2 of some value will give you how many strings of size 2 and digit sum val exist. Is it clear? So this can be simply done, right? You just have 5 maps. So iterate through all your strings, find their digit sum, and let's say the current string S is having D as the sum. So map of S dot size of D, you will add 1 to this. Is it clear? So let me show you the implementation. So first I have taken all these strings as input. Then this is my vector of size 6y because I have to go up till 5, right? The strings, like the string length possible is 5, and I have taken a map. Then first I'm sorting my strings according to their size. Make sure that you're not sorting your this, like if you sort strings by default, they'll get sorted in lexicographical order. Like probably 2, 3, 1 is smaller than 3. We don't want this thing. 1, 1, 1, 1 is smaller than 2. Why? Because strings get sorted in lexicographical order. 1 is smaller than 2. Therefore, 1 will come before 2. So we have to sort these strings according to their sizes. So what I have done, I have first made this vector of pairs in which first thing is size and the second thing is string. Then I have sorted it. Then I have again inserted these strings back into my vector V in order of increasing sizes. Then I'm iterating through these string. Now this total is nothing but the digit sum of S. Then this A and B have the same meaning. So this is just that thing only. If the size, like I'm going through length of S dot size plus 2 minus, if this is odd, minus 1. So this is same thing as that, what I have written here. In case of even, it will be n plus 2. I'll start from n plus 2. Otherwise, I'll start from n plus 1 in case of odd. So in case of odd, I'm starting from n plus 1. Otherwise, I'm starting from n plus 2. N is the size of string S. Length will be less than equals to 2, or I could have done this thing here only. Like length will be less than 2 times size and length plus equals to 2. Now I'm calculating A plus B simply. Why? Like simply iterate. You won't get TLE. Simply iterate and calculate A and B for current. Then in your answer, add length minus S dot size. What is this? The string length minus S dot size is nothing but the size of this string. If the complete size is length, if the complete size is length, if the complete size of this was length and the size of this part was S dot size, so this 2 is nothing but this part is nothing but length minus S dot size, right? So the size of that string, and this is the sum that you required, total minus 2a, and this is length of S dot size, total minus 2b. So these are all the strings that can come in front of string S, and these are all the strings that can come after string S. And combining those strings, you will get a length, a size of like a ticket of size, a lucky ticket of size length. Finally, why I am doing this? See, this is simply adding the current string S dot size and this total to your map. But why I'm doing answer plus plus? Can someone tell me why for each string I'm adding my answer? Like in my answer, I'm adding 1. Why? For each string, I'm doing this, and I'm not checking anything. Yes, perfect. See, in the problem, it's given that I can be equals to j. So what do you think? How many pairs I need to add? I just need to add 1 for each string. And it doesn't matter when in like this size is even or odd, the combined size of this will be something like 2 into S dot size. So this will always be even, and the sum of these two will always be same. Why? Because these two are same string only. So you can also, like, instead of doing this thing, you can also start here, like initialize your answer with n. Then you don't have to do this here. Finally, you can print your answer. Is it clear? Like the implementation can be much more cleaner. But is the idea clear? Okay, so perfect. So now let's go to the next problem. So in this problem, we are given that we have n minus 1 integers, and like we have to construct an array B of size n such that every integer between 0 to n minus 1 appears exactly once in array B, and for every I from 1 to n minus 1, Bi XOR Bi plus 1 should be equals to Ai. So this is a very simple problem. See, we are given, like, let's suppose these were your, this was your array B. So we are given XOR of these, right? So XOR of this, XOR of this, XOR of this, XOR of this, and XOR of this. Now tell me one thing. If I assume that, okay, let's suppose my first element is 0. I'm saying that, okay, I'm fixing it, it is 0. Can you calculate what this element will be? If this is your A0, A1, A2, A3, A4, what will be this element? If I'm saying that Yes, perfect. It will be A0. Why? Because the XOR of these two is A0. So what you have done, you have just done 0 XOR A0. It will be this. Now what will be this element? Right? So on, you can calculate each of these elements, right? Yes, no. Okay, perfect. Now let's suppose this is like you have got 0, then you have got B1, B2, B3, B4, and B5. These are your elements. Now tell me one thing. Is it ever possible to get two elements same? Two elements same in this? Like in the problem statement, it's mentioned that the solution always exists. Like you can read here, additional constraints on the input. It's always possible to construct at least one valid array B from given sequence A. So tell me one thing, is it ever possible that two elements in this sequence are same? It's never possible. Why? Let me tell you why. Because what I have done, I have just said that this will be 0. Maybe it's not 0, I'm wrong. Maybe it is 3. So what will you do? You'll take the XOR of 3 with each and every element. Like this is your modified array. Simply this thing, right? So after doing this also, if two elements were earlier same, they will still be same. So nothing, like what is the element that can come here? Either 0 to n minus 1. You can try for each and every element, but you cannot change. If B2 and B4 are same, they will always remain same. You cannot change those elements. Why? Because if you're applying, if let's say X is coming here, B2 will be X XOR B2 and B4 will be X XOR B4. So you cannot change those two, like those will always remain same. So in the original, in this thing only, every element is unique. Is it clear? Is it clear? Yes, no. If this thing is clear, 90% of the problem statement is solved. Is it clear? Yes, no, anything? Okay. Like, what is the doubt in this part? Can you like just unmute yourself? It will be like, it will be helpful for me to understand. Like, can you tell me what is the thing that is not clear?
Like I'm not getting why the like all the element will be distinct in the array B.
Okay. Like, okay, I'll explain again. So what we were given, we have to make this array B, and we are given array A, which is XOR of these values, right? This is what we are given, and this is what we have to find, right? You can keep yourself unmuted.
Yes.
Okay. So this is what we have, what we're given, and this is what we have to. Now let's say I'm saying that the first element will be 0 only. So you can find these elements, right?
Yes.
We're simply taking prefix XOR. Now I'm saying that my claim is that all these elements, like these 5 elements, will be unique. Now let's suppose, like, how to prove this, that these elements will be always unique. Let's suppose I am wrong, that 0 is not the correct option. There should be something else. So what all possibilities can become here? Like we should have 0 between 0 to n minus 1. Why? Because
yes.
In the input, like in the problem statement, it's mentioned that it's always possible to create an array such that each and every element is between 0 to n minus 1 and all the elements are unique, right? In the problem statement it's given. So the element that should be here is between this thing. So let's say X is here. So if instead of 0 you take X, how will these elements be modified? They will simply become, like, instead of 0 you will have X, instead of B1 you will have X XOR B1, instead of B2 you will have X XOR B2, instead of B3 you will have X XOR B3, instead of B4 you will have X XOR B4, right? Is this thing clear?
Yes.
Now tell me, if B1 and B3 were earlier same, won't this thing will also be same if B1 and B3 are same? X
Yes.
XOR B. So whatever XOR you do, whatever X you choose, these two elements will always be same. There is no way to make them different. But in the problem statement, it's given that it's always possible to make an array such that every element is unique and every element is between 0 to n minus 1, right? So that's why in this array only, every element should be unique. No two elements are same. Because if in this array two elements are same, you cannot do anything to make them different. Is it clear now?
Yeah, yeah, yes, clear.
Okay, perfect. So now we have this thing and we already have all the elements unique. But there is one more thing that we have to do. The maximum element in this array should be less than or equals to n minus, like precisely not less than equals to, it should be n minus 1, right? It should be equals to n minus 1. And if all the elements are unique only, and we have n elements, if the maximum element is n minus 1 and all elements are unique, what will be the other elements? It will be 0, 1, 2, 3, all the way up till n minus 1, right? So we just have to make somehow the maximum element should be n minus 1, right? Yes, no? If the maximum element has to be n minus 1, then now this is a very simple problem. You just have to choose an integer x such that these are all the elements. You take XOR with each and every element, and the maximum of these you get as n minus 1, right? This is the problem. You have to choose some x such that if you take XOR with all these numbers, the maximum that you'll get is n minus 1. You have to choose this x, right? Yes, no? So this can be done using try. So we can, like, if you have solved this kind of problem, find like maximum XOR of any two numbers in an array. This is a very well-known problem, right? For tries of two numbers in an array. So in that, what we do, we just build a try using n numbers, and then we find, okay, for any number, let's say for each number, what is the maximum XOR that we can get. So in this also, we have to do the same thing, just build a try and then find a x. So using this try, we'll find an x for which the maximum XOR with all of these numbers is n minus 1, and that will be our first element. And we'll perform XOR with each and every element in this array. So finally, the maximum element will be n minus 1. Each and every element is unique only. So we'll get all the elements between 0 to n minus 1. Is it making sense? Yes, no? Okay. So let me show you the implementation. Like if the, like I know the try part, like you should have used try earlier in order for that thing to be, but I'm pretty sure that there's another way also to do this. But like once I got to this part that the elements are all unique, I just implemented it using try. I didn't think about the problem that much. So this is the implementation. I have first taken n as input, then I've taken array A as input. So this is just the prefix, like array B built using prefix XOR. Then this is my try. I have inserted each and array, like each array, like each element of array B in my try. Then from 0 to like, actually I don't have to, like the time complexity of this is O of n only. Like probably in up till 2 to the power n. Why up till 2 to the power n? Like instead of going randomly through all the elements, you can do this thing also, that you are only going through these elements, which are array B elements. Can anyone tell me why it's sufficient to go through these elements only as your x, instead of going like finding for each and every possibility? Why it's sufficient to go through each of these elements? Because finally your array should have 0 also, right? Finally your modified array should have 0 also. It's only possible to have 0 in your array B when you took your x as one of these elements, right? Then only you will get 0. Let's suppose this is your array B, and you took your x that is not equals to this, not equals to this, not equals to this, not equals to this, not equals to this. So you won't get 0 in your array B. But you need 0 in your array B, so it's sufficient to your x to be equals to one of these. That's why also this approach is working, because array B is not having elements more than 2n. So eventually you'll get E between 0 to 2n only. So that's why I have blindly done it like this. But if you don't want to do it like this, you can also iterate through array B elements. X will be one of those only. So find the maximum that you'll get using this try for this element. Like if you perform XOR on each of these elements, what is the maximum that you'll get? If this maximum is equals to n minus 1, then this is your first element x. Break your loop. Finally, take for like for each of your array elements, take its XOR with x and print your array B. Is it clear? Okay, perfect. So that's it. And thanks for joining. Bye bye.